Today we will discuss about MIPI. MIPI means what is the full form of MIPI? Mobile Industry Processor Interface. Mobile Industry Processor Interface. What is the use of this protocol? See, the camera captures the image. So camera captures the image, that is the transmitter part. In the transmitter part, so we have a application called camera. And then in the receiver part, the host is maybe processor or any host. So from this, we need to transmit the data by using CSI. That is camera serial interface. This camera serial interface is the high speed data transmission protocol. Okay, so camera serial interface is used for transmitting the data as well as controlling the data, because this transmitter is having one part is CSI part and other part is CCI part. Camera control interface. CCI means camera control interface. So what is the use of this camera control interface means this is the low speed protocol. Here low speed protocol we are implementing or low speed interface we are using. That should be transmit the data up to 20 Mbps supports. So that is a low speed lane. This low speed lane in this transmitter part we have a slave, and the receiver part we have a CCI master. Okay, the master is having again two lines. One is SDA line and other one is SCL line. So one line is master is controlling the clock. So that is the SCL line. Okay. So here the main part is CSI part. CSI is the camera serial interface. Basically, what is the purpose of we are using the CSI part is controlling the information and then transmitting the information from transmitting side to receiving side. In this, how we are transmitting the data is two lanes we are using. One is C-PHY lane and other one is D-PHY lane. D-PHY lane and C-PHY lane. So D-PHY lane and C-PHY lane, phi lane is communicating between the transmitter side to receiver side. So transmitter side to receiver side we are using. In this D-PHY lane having the CSI part, that is unidirectional part. From transmitter side to receiver side, it is transmitting the information in unidirectional. That is having differential lanes. That differential lanes are called as low power, low voltage differential lanes. Okay, so these low lanes will be low voltage differential lanes having either positive and negative. So in this 1 to 4 lanes are there. That means one clock lane and two or more data lanes will be there. So this data lanes either zeroth positive lane and then negative lane. That means DP lane and then DN lane. Differential positive lane and differential negative lane. Similarly, low speed lanes are we are using two lanes. One is bidirectional lane and other one is unidirectional lane. So this bidirectional lane we are using the SDA line, and then unidirectional lane we are using as a clock lane. Okay, so that is the way we are transmitting the information from transmitter side to receiver side by using D-PHY lane. Similarly, we are using the C-PHY lane. So you need to tell that what is the difference between the C-PHY layer and D-PHY lane. D-PHY lane we are having both the data lane and clock lane separately. We are transmitting the information. We have data lane. Okay, that data lane is separate and then clock lane is separate. That is the D-PHY. And C-PHY, it is data lane and clock lane both are combinedly transmitted. Here we have trios we are using. Here lanes we are using. So in this lane two wires only we are using. Here trios means three wires we are using. That means positive lane, negative lane, and trio also we are using. That means high speed data trios. These lanes are also unidirectional. From transmitter side to receiver side, it is transmitting the information. So that means in the transmitter side you are using C-PHY lane. Same C-PHY lane we are using in the receiver side also. So don't change that lanes. That means in the transmitter side you are using C-PHY lane and the receiver side you are using D-PHY lane. That means mismatch will be happen. Okay, and then D-PHY lane we are using 8-bit by 10-bit encoder. What is the use of encoder? Encoder, it will convert the human understandable language into machine understandable language, so it will encode the data by using 8-bit to 10-bit data. Here the encoding will be happened between the data, that is 16 by 7 or 24 by 7 line encoding techniques we are using. Okay, so that is the basic difference between the D-PHY lane and C-PHY lane. See, same will be written here. What is the physical signaling? Differential signaling, two wires per lane. We are using two wires only. So one is DP lane and the other one is DN lane. And here C-PHY lane has three wires we are using in this DP lane and DN lane and DT lane. Okay, three wires are used. Here, how many lanes used for data transmission is 1 to 4 lanes we are using. So in between, one lane you can use, or two lanes you can use, three lanes or you can use, and four lanes you can use. So maximum possibility of usage of lanes in D-PHY lane is four lanes we are using, and then C-PHY lane we are using three trios. So 1 to 3 trios, that means each lane having three trios, that is DP, DN and DT. So it is supporting up to 2.5 gigabits per second. One lane or one trio, it can transmit 2.5 gigabits per second. Data will be transmitted from transmitting side to receiver side. Clear, Ravi? Ah, is that clear? Okay, okay. So encoding techniques. So I told you, encoding means data transmitting from transmitter side to receiver side. So that is by using 8-bit by 10-bit. That means you are having the data is 8-bit. Yeah, tell me. Ah, 8-bit by 10-bit means that is a scrambling and descrambling will be there. So in this 8 bits as an input and 2 bits will be added. That means current running parity, so and then disparity will be added. These parity bits will be added, then it will be converted to 10 bits. Okay, so here your data will be there, so that is the 8-bit data, and then header and tailor we are adding the data. So you can check the YouTube, there is a videos like 8-bit by 10-bit encoders techniques. So in that current running parity, so RC and RP will be added. So why we are adding? uh, Only one bit. Yeah. So that is for here, there is a technique. 8 bits are having. So 8 bits will be divided into two parts. One is 3-bit part and other one is 5-bit part. Okay. In this 3-bit we are adding 1 bit and then 5-bit we are adding 1 bit. So based on that 10 bits will be transmitted from the transmitter side to receiver side. So you are transmitting 8 bits but receiving is 10 bits. Okay, just check that. And 8-bit to 10-bit encoder technique. Okay, so in that how we are adding the running parity bits and then current running parity bits, how we are adding. So in which condition the positive values and negative values will be considered. So that means here bit reversal will be doing that. Suppose 000 we are using, and then for positive value and negative value, and also we are adding some bit reversal condition. That technique we need to learn, so then only you can understand that 8-bit to 10-bit encoder techniques. Okay, similarly you can check that 24 by 7 encoding technique and 16 by 7 encoding techniques in C-PHY layer. Okay, we will discuss later while coming to the further classes. So we will discuss about LTRE, link rate training, link rate training, and then some um, encoding techniques, all these things we will discuss. Okay. So similarly, low speed lanes. So low speed lane is one lane is unidirectional and other lane is bidirectional. Like a half duplex, it will support. Half duplex means someone is talking, other person is listening only, and then other person completes the talking. The next person is try to talk there. Okay. So that is the low speed lanes. We are controlling the data. CSI part, how much data is transmitting, that will be controlled by this low speed lanes. And then pin counts, so here in D-PHY layer more pin counts are used, and here C-PHY lane having less pin counts, because here data and clock will be combinedly transmitted. Embedded data and clock will be transmitted. Here data lane is different and clock lane is different, so that's why, sorry. Pin count. Pin count means, see, we have a number of signals from the transmitter side to receiver side. See, here we are using two lanes. So two lanes means differential data lane and differential negative lane, positive lane and negative lane. So different pins we are using. So that means we are transmitting the information from transmitter side to receiver side, we by using some pins. Okay, so that is the lanes we are having some pins. That is the thing here. And power consumption should be higher here and then lower here. And then electron migration interference. So that should be better and then good in C-PHY layer. So because both the data and clock will be embedded, that's why it will be synchronous with the data. So that's why interference would be less. And then high performance long distance purpose we are using, and then mobiles low power and then pin constrained, some constrained models we are using the C-PHY layers. Okay, so these many differences you will remember means, so most of the interviews times you will explain some of the few points. Okay, so that's what the D-PHY layer and C-PHY layer. Most of the typical applications are smartphones, cameras, tablets, and then automotives, all these things we are using that CSI transmission control and interface. Okay, and then D-PHY is optimized for maximum performance and C-PHY is optimized to reduce the pin counts. That means low power and flexible bandwidth. That's why C-PHY is more used, and then D-PHY is more power consumption. But if you want to transmit the data for longer distance, you can go for the D-PHY lane. Okay, understood? Similarly, this is the architecture of CSI, that means camera serial interface architecture, and then how the data will be flowing. Here we are having application layer. In this application layer, what it is doing means, it is capturing the camera image, whatever the camera we are having, so that captures the image. So and then in the receiver side, it consumes the image. That means it generates the image and it consumes the image. So that is the purpose we are using the application layer. Here pixels is the smallest part of an image. So that smallest part of an image will be converted into pixel to byte format we need to convert. That should be done by using pixel to byte packing or pixel to byte unpacking. In the transmitter side, we are using packing side in the packing, and then receiver side we are unpacking. Okay, why you are unpacking means, whatever the lanes you are receiving the data, so that data will be transferred to again the application layer. So whatever the byte lanes you are receiving from the transmitter side, that should be again converted into unpacked format. Then only we will convert into pixel format. Clear? So that is the pixel in the transmitter side. It packs the data. So and then it converts into bytes format. Depends upon the RGB model. So it will convert. So we have different data types, primary data types and secondary data types. RGB 888, RGB 444, and YUV. So and raw data models we are having. All these are converting whatever the pixel data we are having, that should be converted into bytes format. Okay, and then it supports from 6 bit to 24 bit. So that means 6 bit, 8 bit, 12, 11. So in that way up to 24 bits it can be supporting that. In each data byte we are transmitting 8 bits. That means byte format we are transmitting. That is the main usage of pixel to byte packing format. In the transmitter side we are packing byte format. So in the receiver side we are unpacking. Okay, and then protocol layer. In this protocol layer, this is the packet based transmission we are having. See, this is the packet structure where we are transmitting the, where we are starting the transmission, that is start of transmission, and where we are ending the transmission, end of transmission. In between the start of transmission and end of transmission we are having header, payload, and errors, error packets, all these things. See, in this low-level protocol, we are having header. Header is containing the virtual channels. Two types of 2-bit virtual channels we are having. These virtual channels will be communicating from the transmitting side to receiver side. It will physically not available, but virtually it is available, and it is used to transmit the data from the transmitting side to receiving side. So virtual channels as well as data byte. So 4 bytes of data we are having. In this 16 bits, that means 2 bytes is used to word count, and then one byte is used for what is the data types, and that is 6 bytes and 6 bits, and then virtual channels for 2 bits. That is total 4 bytes of information we are transmitting here in the packet header. So then payload. What is the payload here? Payload is having the data, whatever the data we are having. That means we don't have any RGB data, raw data, all these things. So just pixel data we are having. So that pixel data, how many bytes you are transmitting, that bytes data we are having in the payload. And there is no ECC and CRC, all these things. Cyclic redundancy checks, and then error correcting codes, all these things are outside this payload. And this ECC is the 8 bit. It will detect where the error is happening, where you are getting the error. So error detection purpose we are using CRC and ECC. Okay, it will support that multiple data streams. That means interleaving will be supports. Interleaving means, suppose you are having one packet 1 from the transaction 1, and similarly packet 1 1, packet 2 1 2, packet 1 3. In that way the transaction 1 will be having, and similarly transaction 2 is having packet 2 2, okay, 2 3, and then 2 1. So in that way we are having different packets. So interleaving means the mixing of the data. You are mixing the data. So that means uh, transaction 1 is mixing with transaction 2, and transaction 1 followed by the transaction 2, and transaction 2 is followed by transaction 1. In this way the data will be mixing here. That is the protocol layer will supports here. And then low level protocol layer, so this will be converting byte level synchronization. That means whatever the bytes we are receiving from the protocol layer, that will be synchronized with the clock or not, so we are checking that, and ensures whatever the correct data you are sending, so that ordering will be taken care of here. That means in between the start of transmission and end of transmission, how much granularity you are getting. That means how much disturbance you are getting the data. So that means minimum granularity we need to expect here. So that means at least 1 byte data we need to expect from the transmitting side to receiving side. Okay, that is the use of low level protocol layer. And then in this transmitter side we are using the low level protocol, that is packetization purpose we are using, sorry, protocol layer what is the purpose we are using means, so start of transmission and end transmission, and then synchronizing purpose we are using. Same way here also, the receiver side also we are using. Okay, And then lane management layer, it will distribute the multiple data from the transmitting side, because we are using different file layers. Okay, either D-PHY layer or C-PHY layer we are using. For that, each lane having two different wires. So D-PHY layer, two wires are used, and then C-PHY layer, three wires are used. For each lane, how many data we are distributing, that will be supporting by the lane management layer. And the physical layer, it will be connecting. That means it will converting your data will be converting to electrical signals. So that electrical signal should be transmitting from the transmitter side to receiver side, and then receiver side also receiving the same data. Okay, are you understood what it is happening here? And then how the packet format data we are transmitting from the transmitting side to receiver side. See, supports CSI supports that um, high speed of data. So that means multiple gigabits per seconds we are transmitting for one lane. And similarly, we are using lane scalability. That means high bandwidth of data we are transmitting from one lane to n number of lanes. And similarly, we are also transmitting the data from by using streaming. Streaming means it is grouping the data. So we are receiving multiples of packets. Those multiple packets will be converted into single packet, and then it will be transmitting. That is the streaming purpose. Okay, and then reliable transfer, that means we are checking that error CRC will be there and ECC will be there, error correcting code is also there. So this will correct the data, and if you are receiving ACK from the transmitter side to receiver side, then your data will be transmitted successfully. And then you are receiving NAC from your slave means, so you have an error in your data, you need to correct that. After that, you need to resend again. Clear? So that is the key features of CSI camera serial interface 2. Okay. And then we have the other part called control part. I told you. So in the yeah, in this transmitter side, we have CSI part and CCI part. So this CCI in the transmitter side as well as receiver side also we are having, right? So in this CCI is the low speed control. That means how much data you are transferring from the transmitting side to receiver side by using CSI, it will control here. That is the camera control interface. So this is a two-wire interface. We are having two wires, that is one is bidirectional line and other one is unidirectional line. It will support half duplex transmission. Half duplex transmission means one like walkie-talkie. So walkie-talkie, how we are transmitting the data? So one person is talking, he says that over, then next person will be talking, right? Same way. See, CCI is a two-wire bidirectional half-duplex serial interface. This is mainly using for controlling the transmitter, how the data is transmitting. So it is capable to transmit the data in fast mode also. So I²C having different type of speeds, that is 100 kilohertz and then 400 kilohertz and then 3.2 megahertz and then 5 megahertz. In this way we are having different type of speeds of data. Okay, so those speeds will be controlled by the camera control interface. It will also operates in fast mode. So this is the standard mode, fast mode, ultra fast mode and high speed mode. Okay, in this way we are transmitting the information, we are controlling the information from transmitter side to receiver side. Okay, so CCI is dedicated for interface between the transmitter and receiver. So fully it will monitor and as well as controlling the data. That is the main feature of CCI. See how we are transferring the data from the transmitting side to receiver side. In the CSI receiver, what we are having? Master we are having, because in this is the transmitter side, okay, and then receiver side we are having another data. This is the CCI part. This CCI part is the master in the receiver side. So that master will transmitting the information, which controls the information while transferring the data from by using CSA layer. Okay, so that is the main usage. In this transmit receiver is the master. It will configure the data. So what type of data you are transferring, and then it will also controls the signal like clock signal. Clock signal only generated by the master. Okay, this SDL SCL line we are having the clock signal. That clock signal will be monitored or controlled and generated by the master only, and we are having the addresses from the master to slave. Here single master only we are having, single master and multiple slaves will be transmitting. What is meant by master? Master is controlling the information and asking the information from the slave. Slave will respond accordingly. Slave will respond and giving the data. So if it is the slave is having the data, it will respond accordingly. See, master is asking the data, so then particular slave will be respond and then giving the data. So here SDA line will be operated at the low level. Okay, whenever it is in low level, the data will be in busy condition. The SDA line will be in busy condition. Whenever it is high condition, it is in idle condition, then anyone can use the data line. So will make the transmission of the data in between the transmitting side to receiver side. And then CCA having the frame format. How the frame format we are having? We have a start bit. How we are transmitting the data by using the start bit means SDA should be low. So this SDA line should be maintained low, while SCL should be maintained high here. Okay, this is the low line and this is the high line. At this condition, your master will be initiating the transmission. That is the start condition. After the start condition, the master will keep the address either 7-bit address. Okay, 7-bit address will keep it in the slave side. Then the slave will respond, because here slave 1, slave 2, slave 3 are there. In this slave 1, 101010 is the one address, and then 010101 is the other address. Okay, and then slave n having all ones we are having. Okay, then the master is keeping one address like 10101001. So then particular slave will be responding. Okay, I'm matching with your with your address. I will be the responder. I will be transferring whatever data you want. In that way, we need to set the address. After that, it will do the along with the address bit, we are transmitting the read or write bit. If we are giving 0, you are transmitting the information. That means writing the information to the slave. And then register address. Okay, register address is that internal data register. Okay, which register you want to communicate, because we have a slave. In that internal registers will be there. That internal register will store that 8-bit data. According to that, it will be responding. That means whatever, wherever you are storing the data, there is an internal register, and then we will receive the acknowledgement bit. If you are receiving the acknowledgement bit means successfully placed the address, and then I am placing the data. So n data bytes we are transferring. So 8-bit data we are transferring, that is 1 byte. So 1 byte of data we are transferring, that is 8 bits data. After every transfer of data byte or data bits, so we need to send the acknowledgement bit. That means your data is transmitted successfully or not. Based on the acknowledgement bit only we will know. And then master only stop the condition after transmitting all the data bytes. Then master will be stopping the condition. How it is stopping that? So again, we are initially it is in low condition. That means SDA line should be low condition. That means it is in busy condition. So that means it is operating condition. Then After that, it is pulling to from low to high. So whenever it is in high condition, it is in idle condition. Okay. At that time, the clock signal should be maintained high. Okay, SCL should be high during that while transferring from the SDA line, pulling from low to high. So then only we are stopping the transmission. Clear? Uh, Same way, these are the features 7-bit address, ACK, start and stop control, start repetition. This start repetition we are having, yeah, yeah, okay. See how the transmission will be happen means writing the data and then reading the data. While writing the data, we are putting the start address and then start condition address and then writing write bit along with the address. We are putting the write bit and then we can also keeping the acknowledgement. After keeping the address, we need to get the acknowledgement bit from the slave and also register address. Okay, register. Yeah, yeah. Okay, okay, fine, fine. Understood. So reading the information. So how we are reading the information from the slave means same thing. The master will start the condition and then keeping the address. After that, it will send the data. Okay, register address from the which register I want to read the data, and then this is the start repetition condition. What is the start repetition condition means? I don't want to leave my SDA line to idle. I want to do again another data from the reading. Okay, that means if you are doing the reading the data, again I need to do another data from the slave. Okay, I need to get the another data from the slave. That is the start repetition condition. That means without going to the again start, so the again another data will be transmitting, another data will be receiving. Okay, same thing. Address we are keeping, and then read bit will be keeping. After that, acknowledgement bit, which address location we are getting the data, and then how many data bytes you want to need. After that, after receiving the data, you need to set the ACK or NACK. If you are sending the data, if you are receiving the data successfully means ACK will be setting, or if you are receiving some error means NACK will be setting. This after that the master will be stopping that. Okay, so this is the write read conditions in the CCI part. Understood, Ramya?